Welcome to another lesson of Math 0420 Introductory Algebra. In this video, we will be discussing section 4.3, Solving Systems of Linear Equations by the Addition Method. In this section, we will solve linear systems by the addition method and use the addition method to identify systems with no solutions or infinitely many solutions. Let's start with let's remember back to a previous section where we discussed additive inverses. So let's think of the number 4. What is the additive inverse of 4? Well, the additive inverse of 4 is negative 4. Additive inverses add together to be 0. So the additive inverse of negative 10 would be 10. What if I had 3x? What can I add to 3x to get 0? Well, I can add a negative 3x to get 0. So that's what we will want to do as we try and solve systems of linear equations using the addition method. Example 1. We want to solve the following system of equations using the addition method. Our first equation is x plus y equals 4 and x minus y equals 6. So what is the addition method? How can we make this work? Well, what we want to do is add the equations together. And you may be asking yourself, well, how is that going to help us and why will it work? Well, you'll see as we go through further examples why this will work with this particular example, but in general, we'll have to add some additional steps. In this case, we can just add the equations together. So x plus x gives us 2x, y plus minus y, so we'll add y and subtract y, and that gives us, on the right-hand side, 4 plus 6. And what we end up is 2x plus y minus y is just 2x, and 4 plus 6 is 10. Well, now we have just a single equation that we know how to solve. We can divide both sides by 2. 2's will cancel on the left-hand side, and we are left with x equals 10 over 2, which is 5. Okay? Now we want to plug x equals 5 into either of the original equations. And we can do 5 plus y equals 4. We can solve that by subtracting 5 from both sides. And you get y equals 4 minus 5, which is negative 1. Okay, so our proposed solution is the point 5, negative 1. Now, where did we get those numbers from? Our x value is 5, and our y value is negative 1. Now we need to check that the point 5, negative 1 is a solution to the second equation, which is x minus y equals 6. So we plug in 5 for x minus a negative 1, which is y, and 5 minus a negative 1 is equal to 5 plus 1, which is 6, which is as it should be. Therefore, the point 5, negative 1 is a solution to the system. Now that may seem like magic, so how did it actually work? Example 2, we want to solve the following system of equations using the addition method. So our first equation is 4x minus y equals 22, and our second equation is 3x plus 4y equal to 26. First of all, I'll tell you that we can't just do what we did in example 1. We can't just add those together because we won't get the desired result. what we need to do in this case is we need to multiply the first equation by 4. And we'll do that on both sides. And hopefully as we do this, you'll see why we would choose to do it this way. So we have 4 times 4x minus y, that's the left-hand side, is equal to 22 times 4, which is the right-hand side. So 4 times 4x distributing, we get 16x. 4 times negative y is minus 4y. And 22 times 4 is 88. Okay, and then we can just copy down our second equation. So that's 3x plus 4y equals 26. And now we have a new system that's equivalent to our original system. And at this point, we can add the equations together. So we can add 16x plus 3x to get 19x. Negative 4y plus 4y is plus 0y. And 88 plus 26, you can enter that in your calculator if you need to, is 114. So what happened? When we multiplied the first equation by 4 and got to this equation, we got a variable, negative 4y, that cancels out, adds up together with an additive inverse to give us 0 for one of the variables. So what we end up with is 19x is equal to 114. Then we can divide both sides by 19. The 19s will cancel on the left-hand side, and you get x is equal to 114 over 19, which simplifies to x equals 6. Okay, so we can plug in 6 into one of our equations, plus 4y is equal to 26. 3 times 6 is 18, plus 4y equals 26. Subtract 18 from both sides to try and get y by itself. And we get 4y is equal to 8. We can divide both sides by 4. 4's will cancel on the left-hand side, and we get y equals 8 over 4, which is 2. So our proposed solution is the point x equals 6, y equals 2, so the point 6, 2. And so we want to check it in the other original equation, which is 4x minus y equals 22. So we plug in 6 for x minus our y, which is 2. 4 times 6 is 24 minus 2, which is 22, which is what we should get, so that works out. Therefore, the point we found, 6, 2, is the solution to our system. So how did we know back in the earlier part of this problem that we needed to multiply the first equation by 4? Well, let's now talk about some steps as to how we solve these using the addition. Okay, steps for solving linear systems by addition. Step 1. If necessary, rewrite both equations in the form ax plus by equals c. Remember, that's standard form. Step 2. If necessary, multiply either equation or both by appropriate non-zero numbers so that the sum of the x coefficients or the y coefficients is 0. Step 3. Add the equations from step 2. The sum should be an equation in one variable. Step 4. Solve the equation in one variable. Step 5. Back substitute the value obtained in step 4 into either of the equations from the beginning and solve for the other variable. And finally, step 6, check that the solution works in both of the original equations. Example 3, we want to solve the following system using the addition method. So our first equation is 4x plus 5y equals 3, and our second equation is 2x minus 3y equals 7. Okay, what we want to do is we want to find some multiple of one of these equations that will cause either the x variable or the y variable to go when we add the two equations together. Now, 3 and 5 don't have any common factors, they're both prime, but 4 and 2 do have a common factor of 2. So what we can do is to try and get rid of the x is find something that we can multiply this second equation by to get a negative 4x. Well, we can do that by multiplying this second equation by negative 2. So we multiply the second equation by negative 2. So on the left-hand side, that's negative 2 times 2x minus 3y. And on the right-hand side is negative 2 times 7. Negative 2 times 2x is negative 4x. Negative 2 times negative 3y is plus 6y. And negative 2 times 7 is negative 14. Okay, so our new system of equations is 4x plus 5y equals 3, and negative 4x plus 6y equals negative 14. Notice that in our new system, if we add the x's together, those will cancel out. So 4x minus 4x is 0x, 5y plus 6y is 11y, and 3 plus a negative 14 is negative 11. Divide both sides of this equation by 11, and the 11's cancel on the left, and we get y equals negative 11 over 11, or negative 1. So our y value is negative 1. Now we can plug back into one of our equations to solve for x, and we can do 4x plus 5 times our y value of negative 1 equals 3. And so we have 4x minus 5 equals 3. We can add 5 to both sides of that equation, and we get 4x equals 3 plus 5, which is 8. Divide both sides by 4. 4's cancel on the left, and we get x equals 8 over 4, which is 2. So our proposed solution is the point 2, negative 1. All we need to do now is plug into the other original equation to see if it works. 2 times 2 minus 3 times negative 1. 2 times 2 is 4. Negative 3 times negative 1 is plus 3, which gives us 7, as it should. So that checks out. Therefore, the point 2, negative 1, which we found, is the solution to our system. Okay. Example 4, we want to solve the following system using the addition method. Our system of equations, the first equation is 2x is equal to 9 plus 3y, and 4y is equal to 8 minus 3x. So what's the first thing you notice about these equations? Well, the first thing you should notice is that neither one of those are in standard form. These equations are not in standard form. And remember that standard form is ax plus by equals c. So the way we can rewrite that is by moving the 3y to the left in the first equation. So we get 2x minus 3y is equal to 9. And we can add 3x to both sides in the second equation to get 3x plus 4y is equal to 8. Okay, so now we have our system of equations in a format that we can use the addition method. Now notice that for the x's, we have a 2 and a 3. Both of those are prime, so we don't have any common factors. The same is true for y. We have a 3 and a 4. So what we will need to do is we're going to have to multiply both equations by some number. Okay, and the way we can do that is we'll do, if we want to get the x's to cancel, okay, then we need to multiply this one by negative 3, and that will give us a negative 6. And then we can multiply this equation by 2. 3 times 2 will give us a positive 6, and the x's will cancel. So let's write that out. So we want to multiply the first equation by negative 3. And multiply the second equation by 2. So let's do that. Negative 3 times the left-hand side of the first equation is 2x minus 3y. is equal to negative 3 times 9. We can distribute and we get negative 6x. Negative 3 times negative 3y is plus 9y. Negative 3 times 9 is negative 27. And our second equation, we can multiply it by 2. Left-hand side is 3x plus 4y. Right-hand side is 8, so we multiply both sides by 2. And we get 2 times 3x, which is 6x, and 2 times 4y, which is plus 8y, is equal to 2 times 8, which is 16. So, we have a new system. And our new system is negative 6x plus 9y is equal to negative 27. And 6x plus 8y is equal to 16. Now notice that our x's will cancel out when we add that equation together. So we want to add negative 6x plus 6x is 0x, 9y plus 8y is 17y, and negative 27 plus 16 gives us a negative 11. Okay, we can divide both sides by 17. 17's cancel, and we get y is equal to negative 11 over 17, which is kind of an ugly number. So now we can plug in that negative 11 over 17 into one of the original equations, and we'll use the first one. 2x equals 9 plus 3 times negative 11 over 17. Okay, left-hand side stays the same. 2x is equal to 9 plus 3 times negative 11. We'll change that to a minus. So it's minus 33 over 17. And to make sure we have a common denominator, I'll multiply the 9 by a clever 1, which is 17 over 17. 9 times 17 is 153 over 17 minus 33 over 17. And that's 2x. So 2x is equal to 153 minus 33, which is 120 over 17. Divide both sides by 2, and you get x is equal to 60 over 17. Now that, like I said, much more complicated looking problem. So our proposed solution is the point 60 over 17, negative 11 over 17. Okay, we want to check the second equation. So 4 times y, which is negative 11 over 17, is equal to 8 minus 3 times x, which is 60 over 17. Okay, so 4 times negative 11 over 17 is negative 44 over 17. And we can convert 8 into 17ths by multiplying it times 17 over 17, which is 136 over 17. And negative 3 times 60 is negative 180 over 17. And 136 minus 180 is negative 44. And since those two things are equal, that is a solution to that equation. So therefore, since this point, 60 over 17, negative 11 over 17, works for both equations, it's therefore a is a solution to both equations and is thus the solution to the system. All right, now for a little bit of a different example. We're still going to solve this system of equations using the addition method, but our system is x plus 2y equals 4 and 3x plus 6y equals 13. So how can we get the x's to go away? We could do the same thing with the y's, but we're going to focus on the x's. We have a 3x here, so we could multiply this first equation by negative 3, and we'd have negative 3x, and those would cancel. So what we'll do is we'll multiply the first equation by negative 3. So negative 3 times x plus 2y is equal to negative 3 times 4. Distribute the negative 3, we get negative 3x. Negative 3 times 2y is minus 6y. And negative 3 times 4 is negative 12. Okay, so our new system is negative 3x minus 6y is equal to negative 12, and 3x plus 6y is equal to 13. So negative 3x plus 3x is 0x, and negative 6y plus 6y is plus 0y, and negative 12 plus 13 is 1. 0x plus 0y is just 0, and we have 0 is equal to 1. Well, when is that true? We're going to put a big uh-oh here, because 0 is never equal to 1. So if you get something that's a contradiction, that means there are no solutions. This is called an inconsistent system. Therefore, there are no solutions. Okay. Okay, example 6. We want to solve the system of linear equations by the addition method. Our first equation is x minus 5y equals 7, and our second equation is 3x minus 15y equals 21. Again, we're going to focus on trying to eliminate x, and we have the same situation as in our previous example, where we have 3x and x, so we can multiply the first equation by negative 3. So negative 3 times x minus 5y is equal to negative 3 times 7. Okay, we distribute the negative 3, we get negative 3x. Negative 3 times negative 5y is plus 15y. It's equal to negative 3 times 7, or negative 21. So our new system is negative 3x plus 15y equals negative 21. And 3x minus 15y equals 21. So when we add negative 3x plus 3x, that's 0x. 15y minus 15y is plus 0y. And negative 21 plus 21 is 0. So what we have is that 0 is equal to 0. So when is that true? Well, 0 is equal to 0 always. So no matter what our x and y values are, it does matter what our x and y values are, but there are infinitely many solutions to this system because those two lines are the same. So this system has infinitely many solutions. So if you choose an x value and you find the y, that'll be true in both equations because the equations are effectively the same thing. Okay, that is the conclusion of section 4.3, solving systems of linear equations by the addition method. Good luck on your homework. Please let me know if you have any questions.